Hello, Honors Algebra students. Mr. Lawrence here, and Metigatos had requested that I put a review video up, so here it is. Let's get down to it. Topic 9 review video. First of all, graphing parabolas. Let's talk about the width of a parabola in the form of y equals ax squared. Yeah, no b term or c term, they're both 0. Now, one thing you could do if you don't get this yet is you could always make a table comparing them, and you notice that I have put down three equations: y equals x squared, y equals 3x squared, and y equals 1/3 x squared. You should know what's going to happen with them. If not, let's plug in some numbers. Let's start by plugging in 0. If I put 0 into the first one, I get 0, and then I get 0, and then I also get 0. These are all going through the origin. In fact, the vertex will be the origin if you use x equals negative b over 2a. So that doesn't really tell us much, but here's where it'll become pretty obvious. Okay, if I put 1 in and negative 1, I'm going to get 1 and 1 out, right? On the second one, if I put 1 in, I'm going to get 3 and 3 out. Well, if you think about what that means, let me get a graph paper. Oh, hold on, let's do this one. The third one's going to get me a 1/3 and a 1/3. If you're not sure, pause the video and figure it out. But let me get a sheet of graph paper out here. And let's see, in fact, better yet, let me go to Desmos.com. That'll be really cool to show you on there. It'll be a lot better. Hold on a second. All right, let's go to Desmos, Desmos.com. All right, so the first equation was y equals x to the second power. And there it is. And sure enough, if I go to 1, look at that, I'm at 1, right? Okay, but then the next equation was y equals 3x to the second power. And see, that's the blue one. And look at how it got skinnier. Why? Because I'm multiplying x squared by 3. So all the values are tripling. So if I go back to this table and I figure out what y is when x is 2, well, I'm going to get 4. And when it's negative 2, I'm going to get 4. But over here, it should be 12, right? So this graph is climbing in 3 times faster than this graph over here, which would be more of our standard. Whoa, I don't know what that is. It'd be more of our standard parabola without the extra little squiggle wiggles. All right, let me see if I can get rid of those. All right. Okay, close enough. So, it's going to be skinnier. Well, what's going to happen with the 1/3 out front? Well, a lot of you don't realize this yet. You should, but if I multiply 1/2 times 10, that's the same as dividing 10 by 2, right? That canceling out that we do, the Wonder Woman thing, that's division. So when I have a 1/3 or a 1/5 or something like that, I'm dividing. So I'm going to take that 4 that I got for x squared, and it's going to be 1 and 1/3, or 4/3, right? Oh, I wrote 1 and 1/4. Sorry about that. Okay. So 1 and 1/3, and then again, because of symmetry, I'm going to get 1 and 1/3 over here. All right. So this one is going to flatten out. It's going to be real wide. It's not going to climb nearly as quickly. Yeah, so if I go back to Desmos real quick, hold on, let me get pointer mode so I don't start drawing on Desmos, and I go for a third equation, and I put y equals 1/3, oops, x, I got to remember to square it. There we go. You see how it got wider? The red one was the original. The blue was the one with a a was greater than 1. And sorry about that. I had a sneeze coming on. I can't pause the video. And tried to cover up to not blow your eardrums out. All right. And then when I had a less than 1, greater than 0, it got even wider. Now, what's going to happen if I make these negative? Well, the only thing that's going to happen is the parabolas are going to flip. they're still going to keep their thickness or their width. That's not going to change. All right? Okay, so let's see here. There's the tables. So right now, I'd like you to order those three equations from most wide to least wide to skinniest, right? So you can pause the video and try that. Here comes the solution if you've tried it on your own. And let's see here. The widest is going to be the one I divide by the largest number. I'm dividing by 8. Multiplying by 1/8 is the same as dividing by 8. So this is going to be the widest. Y equals 1/8 x squared. Now, of the two remaining, which one is divided by a bigger number? Well, of course, it's the 4, or the 1/4. So this will be the next widest out of these three. And by default, that leaves y equals 1/2 x squared. If you still don't get what I'm talking about, I'll try to explain it one last time. Whatever I get for x squared on this equation here, I'm going to divide by 2. I'm going to cut it in half. But on this one, whatever I get for x squared, I'm going to divide by 4. So I've got to share the same thing with 4 people instead of sharing with 2. Each person's going to get a smaller amount for this one, isn't it? But on this one, I got to share with 8 people because I'm dividing by 8. All right, here's 2 parabolas, and actually there's a third one down here. If you'd like to pause the video and try to graph them on your own, that'd be awesome. I'm going to go ahead and graph them. You know, if you haven't tried it, please pause the video. All right, first thing I'm going to do is identify A, B, and C. So I'm going to go A, B, C. Easy as -1, 0, 9. And I'm going to go looking for my vertex. So x equals negative of b over 2a. Now since b is 0, I know the x-coordinate of my vertex is going to be 0. I also know the line of symmetry. The line of symmetry is going to be x equals 0. In other words, it's going to be the y-axis. I'm going to put a line of symmetry in here. And you watch, the parabola will be perfectly symmetrical about this line. This line will not be a part of the parabola, but it'll be like a mirror image on both sides. Okay, so now, if I make a table, oh, I guess I should find the y-coordinate of the vertex, shouldn't I? Yeah, so let's do that. So let's put 0 in as the x-coordinate of the vertex. And if I put 0 in here for x, I get 9 out, don't I? So that means the vertex is at 0, 9. All right, there's my vertex at 0, 9. Okay, now if I put a 1 in, I'm going to get 1 squared is 1, negative out front, so I'm going to get 8. If I put -1 in due to symmetry, I'm going to get 8 also. Let's put 2 in also to see what happens. All right, so if I put 2 in, I'm going to get 4, so it'd be -4 plus 9 is 5, and then -2 will yield the same result. So I'm going to get 5 here. I'm sorry, I didn't fill those in, did I? 8, -2 will also be 5. And now I can draw my parabola. And you can see it'll be perfectly symmetrical. Now, again, on paper and pencil, you guys can do such a better job than I can with this airliner. But anyway, it's going to look something like that. All right, the second one. The second one over here. Well, first thing I'm going to do is I'm going to find A, B, C. Easy as 3, -2, -4. Okay, so let's go find the vertex. So I'm going to do x equals the negative of b, notice it became a positive, over 2a, which will be 6. 2 times 3 is 6. So the x-coordinate of the vertex is 1/3, which also means that the axis of symmetry will be x equals 1/3. All right, I'm going to go ahead and put that one in. I might make it real skinny on this one. After I do it 1/3, that's going to be a little bit harder to do. I'm going to be kind of guessing where it's at, right? Yeah, that's not the right position yet. Just be patient. I'm going to go ahead and make him a little bit skinnier. There we go. That's probably a little bit too skinny. There we go. I can see that okay. And then let me see if I can move that. Oh, wrong one. It's not cooperating. Let's see if I can do it with my mouse instead of with the airliner. There we go. Okay, so approximately there. Something like that. It's going to be a little bit off. So I'm going to go to a table. And I think I better recopy down the equation while I do my work for the table because I can't hold it all in short-term memory. 3x squared, that is. All right. And that's what, minus 2x and minus 4. Yikes, come back here. All right, minus 2x minus 4. And I know that right now the x-coordinate of my vertex is 1/3, right? So I'm going to find the y-coordinate of the vertex. So y is going to equal 3 times 1/3 squared minus 2 times 1/3, that's 2, minus 4. All right, well, this is going to be 1/9, and I think that's going to come out to be 1/3 on the nose, right? And so that's going to be minus 2/3. That's going to be minus 4, although I think I'm going to read minus 12/3 because I'm dealing all in thirds, right? Okay, so let's see, negative 14/3, negative 13/3. I don't want to graph negative 13/3, so I'll change that to a mixed number, negative 4 and 1/3, right? So negative 4 and 1/3. All right, so let's go here. So it's going to be right about there. There's my vertex. All right, now I'm going to pick some points on either side of the vertex. Normally I like to pick 0, and I can, but it's going to be so darn close, it's not really going to help. So I'll pick 0, and I'm going to put, get negative 4 out, right? Okay, so that'll be there. Now, to go use symmetry, I'm not going to go to 1, I'm going to go to 2/3, right? Because these two coordinates are 1/3 away. I got to go 1/3 on the other side and get negative 4. But I really don't have a good picture of my parabola because of this. Like, they're too close together. So let me try another point. Let me see here. 27, no, that's going to be too big. I was going to use 3, but 3 is going to be too big. Let's go ahead and go with, let's go with 1 on this side. No, sorry, negative 1. Yeah, negative 1 on that side. And then notice these are 1 unit away, so I'm going to go 1 unit away. So it's going to be 1 2/3, or better yet, 5/3, right? Because that's a full unit away. Yeah, I'm trying to use symmetry. So let me come back here and go 3 times, oops, wrong number, getting ahead of myself. Okay, we're going to have a 5/3 squared, right? 5/3 squared minus 2 times 5/3. And I'm not going to put minus 4 again. I'm going to put minus 12/3, right? Okay. So when I do this, let me see here. I'm going to get 25/9, so it'll be 25/3 minus 10/3 minus 12/3. And it looks like that might be 1 on the nose, right? Negative 22. Yeah, that's going to be 1. Oh, I like that. That worked out nice. So I'm going to go up and plot 1 2/3, 1. So 1 2/3 would be about here, up to 1 would be there. And then negative 1 will have the same result. Okay, so now I can get a better idea of what my parabola is going to look like. By the way, I knew the first parabola that I did, sorry, there goes my airliner, was going to open downward. And I knew that this one was going to open upward. because A's sign, if A is less than 1, if A is less than 0, it'll open downward, and if A is greater than 0, it'll open upward. All right, so here's a third one for you to do. Okay, I'm going to let you do it totally on your own, and I'm going to show you the answer in Desmos just to save time in the video. So go ahead and do it. When you're ready, check out Desmos. All right, so here comes Desmos. And so let's see here. I need to get rid of this, and I'm going to need a 3x squared. And oh my goodness, I can't remember. Is it minus 10x minus 8? All right, so then we're going to go minus 10x minus 8. And let me zoom out a little bit. It looks like my vertex is going to be at about 1 2/3 and negative 16 1/3. My zeros are going to be at 4, 0, and at negative 2/3, 0. My axis of symmetry will be x equals 1 2/3. Another point here would be 0, negative 8. Now, if you look at that's 1 2/3, I'd have to go 1 2/3 the other way to get to this point, right? Okay, so there we go. So there's your graphing parabolas. So what else are we going to put in this video? Well, we're going to do some vertical motion, but I'm actually going to pause the video right now, and I don't want it to get too long, and so I'll do it in a second segment because I've got to solve quadratics by factoring as well, and then completing the square, and those will go a little bit quicker. All right, so we got a few more things to do. Those will be in the next video. All right, Mr. Lawrence signing off. Have a good night, everybody.